Welcome friend. In this new video I will uh, define the shift operator, the identity operator, and we uh, here explore the relation between the shift operator and the forward difference operator. We delta of f of x equal to f of x plus h minus f of x. So there is a difference of the term or the forward term f of x plus h and the given term f of x. But when there is a no difference, means there is a no such a uh, shifting of the subtraction of this term, means whenever the function is remains as it is, and that operator is called as a identity operator, and we denote this by 1 identity operator, 1 of f of x, it gives us f of x. There is a no calculation of any kind of difference or any kind of shifting. Now we defined another operator, and it is called as a shift operator or an displacement operator, and it is like this: f of e of f of x equal to f of x plus h. So it gives a difference displacement of x to x plus h, and therefore it is called as a displacement operator, or it shifted x to f of x, x to x plus h. So these are the three operator. This is identity operator. It will do not change the function to any of the shifting or any of the difference. Therefore it is an identity operator. This is forward difference operator, and this is displacement operator or shift operator. So friend, how to calculate this, how to operate this? If we would like to calculate this, this is equal to e of f of x equal to f of x plus h. I have written once again, and here delta of f of x. So delta of f of x equal to f of x plus h, means e of f of x minus f of x, and for this f of x I will write 1 into f of x. So we take e minus 1 as a common, e minus f of x 1 into f of x, and hence we get the first operator relation e minus 1 equal to delta, or e equal to 1 plus delta. This is the first relation we get from the definition of the operators: forward difference operator, identity operator, and shifting operator. Now let us calculate the e square of f of x. Again friend, remember that it is not a square. E square means it is a repetition. We do not have to take the square of this, but we are just repeating this two times, means e of e f of x. So e f of x is nothing but e of f of x plus h, and there is a displacement by h. Again there must be a displacement by h, so this will be f of x plus 2h, x plus h plus h, that is x plus 2h. Similarly, e cube of f of x equal to 3 times f of x equal to e of e square f of x equal to e of f of x plus 2h. Now there is addition, displacement from these two, we have to add 1h. Whenever we add 1h, this will be x plus 3h. So we get f of x plus 3h. Then e raised to n f of x equal to f of x plus nh. So we are there is a displacement up to n. Now we define E inverse of f of x. So whenever we have e of f of x, there is a displacement, there is a addition, and in this inverse we subtract h. So f of e inverse f of x is nothing but f of x minus h. So this is the these are the operators. Now friend, we see one important result regarding this operator. For example, whenever we have f of x equal to x, my function f of x equal to x, then let us calculate the e square f square of x equal to e square. E square, that is this is nothing but uh, the e square f of x square. So f of x is x. So x f square means x square equal to e square means e double e operator operate two times e on x square equal to e of x plus h whole square equal to x plus 2h whole square. Now when we consider e of f of x whole square, then e of x whole square equal to e means x plus h whole square. So these two values are not equal. X plus h whole square is not equal to x plus 2h whole square, and hence we get the result that e square f square is not equal to ef whole square. So remember these things. This is not possible for these operators. E square f square is not equal to f of x. Now if we have more than if we have two functions, then how to add that two functions? Suppose we have the functions f of x plus g of x plus plus like this, and let us take the difference of this. Let us operate the delta on this operator. By definition of delta, what is definition? Delta of f of x equal to whatever may be here in the right of this delta. It will gives us x plus h minus f of x. So delta will operate in a such way that it will calculate the difference of these two. So this is the term. So delta will calculate the difference of f of x plus h plus g of x plus h plus minus f of x plus g of x plus. Okay, and this is equal to f of x plus h minus f of x plus g of x plus h minus g of x, and this will be n times plus whatever may be time. So this is nothing but delta of f of x plus delta of g of x plus. So this gives me a important property of delta, that delta is a distributive her the addition. We can take the delta, we can operate the delta on every of these terms. Now what if we consider a delta of c into f of x? So here delta of c into f of x, apply the definition whatever may be here. Delta gives the difference of this next term will be f of c into f of x plus h minus the given term c into f of x. So this is equal to c common, and we have f of x plus h minus f of x, and this is nothing but c into delta f of x. So friend, in this manner we can take this c as a constant. C is where c is a constant and there is nothing change. Likewise the derivative, when we operate the derivative function on the uh, x into f of x, constant c into f of x, then c remain as it is. There is no change in the constant. Okay, now delta raised to p into delta raised to q on f of x, if we operate this, so delta raised to p means we have to consider delta into delta here, p times into then here we have to operate this delta q times delta into delta q times on f of x. So this p times and this q times we are operating on f of x, but the total are delta raised to p plus q times f of x. Okay, so there is a addition of this power. Similar function, properties hold for e function e raised to p into e raised to q of f of x is nothing but e raised to p plus q into f of x. So this is the one of the important property of the operator delta. Now Another result, let us see about the operator DE and delta. Uh, Let me calculate E into delta of f of x equal to E into delta f of x. This is f of x plus h minus f of x equal to E of f of x plus h minus E of f of x equal to f of x plus 2h minus f of x plus h. Okay. Now delta E of f of x equal to delta of f of x plus h equal to, by definition, this is f of x plus 2h minus f of x plus h. See the right side of the both the results, and from this we have E into delta equal to delta into E. So there is a commutative property for this E and delta operator. Now let us prove one problem. Suppose that let us prove this. Prove that e raised to x equal to delta square divided by e into e raised to x equal to e into e raised to x divided by delta square e raised to x. So friend, consider the RHS. RHS equal to, in the RHS we have, this is equal to delta square e inverse operating on e raised to x equal to e raised to x plus h divided by delta square e raised to x equal to delta square e inverse operating on e raised to x means e raised to x minus h into e raised to x plus h divided by delta square e raised to x, and we write this as e raised to minus h into delta square e raised to x into e raised to x plus h divided by delta square e raised to x. So this term will get cancelled, and we have e raised to minus h into e raised to x into e raised to h. So this power will be cancelled and we get e raised to x, and that is the LHS. So this proves the problem. Now friend, I hope you have enjoyed the properties of the operator delta and operator E, shift operator, as well as identity operator. Thank you friend, thank you for watching the video.